Okay, so this is the second math tool. So is significant figures. Why we need significant figures? And let's have a look at these high heel shoes. And if I want to know the height of the heel, I can use a ruler to measure that. This is a millimeter ruler, so I can see. And if I go with the green line, and it's already past 9 centimeter. So I will right here. It's already past 9 centimeter, and since here is not very clear, I can't see the exact location where the green line located. And I will just zoom in here, this part. Okay, so we all agree that it's over 9 centimeter, and there is 10 marks between the 9 and 10. So this is each one will be, this is 1 centimeter, so each one will be 0.1 centimeter. This is 0.1, this is 0.2, this is 0.3, 0.4, 0.5, 0.6, so on and so forth. And you can see it's already past 0.5, right? We all agree it's already past 9.5. So everybody can see it's already past 9.5, but haven't reached to 9.6 yet. Then we have to guessing after this 9.5. Each student can see, okay, it's 9.55. Looks to me it's in the center, so I can call 9.55. Or another student said, I think it's 9.56. It's a little bit more over the center. Both are correct. So the last digit is the guessing. Different people can give different estimation. Okay, so then come back to Sigfigs. So all those 3 digits are significant to this measurement. And the first 2 digits is for sure, so it's called certain digit. The last digit and different people can give different estimation, so this is called guessing digit. The certain digit can be more than 1, and the guessing digit can only be 1. So certain digit plus guessing digit, the total number is the number of significant figures for this measurement. Okay, so let me summarize this together. Every measurement has some level of uncertainty associated with it, and also every measurement should have one, but only one estimated digit. Others are all certain digit, like 9.55. This one is the only guessing digit, and the others are all certain digit. So the number of Sigfigs, which is carry meaning to this measurement, and equal to all certain digit, which is here for this measurement, and one uncertain digit. So together for this measurement, 9.55 centimeter for the heel of the high heel shoes, which is 3 Sigfig. And significant figures we also call Sigfigs in short. Okay, so now let's do some practice. And before we do practice, let's get familiar with some rules, especially to determine zeros. Rule number 1, all non-zero digits are significant, like all the measurement numbers in this one, 9.55, are significant. So 1, 2, 3. So we have 3 Sigfigs. And the problem usually comes from the zeros. Some zero count as significant, but some not. So now I have to look at which zeros count and which doesn't count. 0.00955. Look at this number. So there are some leading zero. That's the zero before the non-zero digit. Are never significant. So that means this one doesn't count, this one doesn't count, this one doesn't count. Only these three non-zero digit count, which is still 3 sig fig for this number, for this measurement. Okay? Leading zero, never significant, never count. Okay? And the confound zeros, that is the zero between non-zero digit, like those 3 zeros, are always significant. So non-zero digit always significant, which is 4. And this 3 zero confound zero also significant. So I have 7 sig figs. And the zeros after the non-zero digit usually is the troublemaker. So that causes trailing zeros are only significant when accompanied by a decimal point. So if you have a decimal point, this will count. If you don't have a decimal point, this 3 doesn't count. Okay, so for this number, since it has trailing zero and also it has a decimal point with that, so all these 3 zero count with these 3 non-zero digits, so 6 sig fig total. And for the zeros, that trailing zeros that doesn't have a decimal point with it, doesn't count. So this 3 doesn't count. These 3 non-zero digit count. So I have 3 sig figs. Okay, so I'm sure you should be fine with the first three rules, but only this one, when you have trailing zero, you will need to check, do you have a decimal point? That will make the number different, sig fig number different. Okay, so let me wrap up with this picture. And when we need to determine the sig figs, let me change to the color. When we need to determine the sig figs, and for non-zero digit, like those non-zero digit, always count to 0 digit, and you have to see depends on their location. The leading zeros, so 0 before the non-zero number, never significant. If you look at this number, those 3 zero doesn't count. That is the leading zero. And for the confound zeros, that 0 between non-zero digit, always significant. Okay, so there's a 3 here, confound 0, so these 3 count. And then the trailing zeros. Trailing zero depends on, do you have decimal point? If you do have decimal point, that will count. If it doesn't have decimal point in the number, then it doesn't count. So do we have decimal point? We do. So if we do have decimal point, these 3 also will count. So then plus 1 2 non-zero digit, which is 2 sig fig. So total I have 8 sig fig for this number. Okay, so we are now familiar with all of the rules for determining the sig figs. Let's do some practice. Okay, so 26, all non-zero digit count, so it's 2 sig fig. Let me change the color. And this is trailing zero. Trailing zero count or not, it depends on, do you have decimal point. If you do have decimal point, then count. If it doesn't have decimal point, then it doesn't count. So we have 5, and then these 2 count because I have decimal point, which is 7 sig fig. This number, we have leading zero. Leading zero never count. It doesn't matter you have decimal point or not. So I only have 4 non-zero digit, which is 4 sig fig. This one is certificate notation. When we look at the sig fig of the certificate scientific notation, we only need to focus on the C part, the coefficient part. So if it's only one non-zero digit, it's one sig fig. If we look at this one, it has 0, but it's confined 0. All confined 0 count. So I have 3 plus 1 0 plus 1 2 3 4 4 after the 0. So I totally have 8 sig fig. Okay, so this is how we determine sig fig. Usually you need be more careful when your 0 are in the end of the number. And how we determine the sig fig in the mathematical operations. When we perform your calculation, your final answer must reflect the number of sig figs in the least accuracy or most uncertain in the measurement. So, for example, if I have a plastic cup which is 36.03 gram, and then I have a penny which is 2.53588 gram, I put those both on the scale and it showed me 38.56588. I add them together. I punch this into the calculator, and it's give me this. It's give me this total. So does all of these significant to this measurement? No. So why I only have 38.57, which is 4 sig fig? And that because when you have addition or subtraction and you need your final answer, need to go by the original value. This is the original value with the fewest decimal places. So I have 2 decimal places here. I have 1, 2, 3, 4, 5. 5 decimal places in this number. Fewest one is 2. So that means my final answer only have to have 2 decimal places. But why I changed 6 to 7? Because the number after the 6 is 5. So I need to round that up. Therefore, I end with 38.57. That's for addition and subtraction. And if I want to do some multiplication or division, so will I follow the same rules? No, the rules change. So if I have used this number divided by this number, I get, if I punch into my calculator, I get this number. But not all of those digits carry meaning to the measurement. I have to determine which number is significant or how many sig figs for my measurement. When you have time or divided and you need your final answer need to go by the original values with the fewest sig figs. Okay, so let's have a look at which one have few sig fig. How many sig fig this number has? 1, 2, 3, 4, 5, 6. I have 6 fig. How many sig fig this has? So 0, leading 0 doesn't count, so I have 3. Fewest means 3. So my final answer should only keep 3 sig fig, but 8 should be rounded up. So I have 7.64. Okay, so this is the rules when you do mathematical calculations and how to determine your sig fig for your answer. Okay, so now let's do couple practice. With this one, when I do water displacement to measure the density of some solid, I have the 2 volume subtract with each other, and this number, this volume minus this volume. So I will have, if I put those numbers into the calculator, I will get 7.142 milliliter. Okay, but not all those digits are significant. I need to go by the, since it's minus or add, I will go with the fewest decimal places.